I will explain about how to read a psychometric charge. So, firstly, what is psychometric charge? Psychometric charge is a graphical representation of the physical and thermodynamic properties of air. They have four important elements in psychometric charge, which is dry bulb temperature, relative humidity, specific humidity, and dew point temperature. So let's move on to read psychometric charge. Firstly, we need to identify the axis. Look along the bottom of the charge to find the dry bulb temperature. The horizontal of x-axis of the chart denotes the various temperature readings in Fahrenheit or Celsius. Use the vertical line extending from this axis to trace the measurement. Total the charge. Each level temperature will have one vertical extending from the axis. If the measurement that you are looking for is between the level temperature, estimate its location. Secondly, we need to find the humidity ratio level on the right vertical axis. The vertical or y-axis on the chart marks the amount of moisture per pound or kilogram. Use the horizontal lines extending from this axis to trace the humidity ratio to top the charge. The humidity ratio is sometimes referred as the mixing ratio or absolute humidity. And then we need to locate the uppermost curve line on the chart to find the saturation curve. This curve connects the x and y axis and marks the relationship between temperature and absolute humidity when the relative humidity is 100%. Along this line, note that the wet bulb temperature and the dew point are always equal to the dry bulb temperature. The curved line gets its shape due to a rise in absolute humidity when the temperature increases. Next, we need to follow the interior curve line to see various levels of relative humidity. On the chart, you will notice various lines that follow the curve of the saturation curve. This marks the relationship between temperature and pressure when the humidity is less than 100%. In most cases, each line away from the saturation curve represents a 10% decrease in saturation. So, for reading interior marking, firstly, we need to look on the right side on the chart to find the vertical dew point line just to the right of the y-axis. Find the line with the dew point measurement in degrees Fahrenheit or Celsius. If you're having troubles in the line on the chart, use a ruler to align the hash marks with the line on chart. Since the lines of dew point remain constant and flat throughout the charge, the dew point does not change according to the dry bulb temperature. Secondly, locate the vapor pressure line to the right of the dew point line, next to or along the same vertical line as the dew point measurement. They will be marking denoting the various vapor pressure in inches of mercury or millibars. Again, if you are having trouble following the line on the chart, use a ruler horizontally to align the hash marks on the vapor pressure with the line on the chart. Like dew point, vapor pressure remains constant even if the dry bulb temperature changes. Next, we need to identify two non-measurements that are on the chart. When solving a problem involving a psychometric charge, you only need two measurements to read the chart. Pick any two non-measurement available and plot them on the chart where the line intersects. Normally, you should give preference to measurement of dry temperature, absolute humidity, dew point, or vapor pressure. However, you can also use relative humidity, enthalpy, and specific volume to make an estimate conclusion. Use a ruler to locate other measurement at the point of temperature. Once you unmark the point where the unknown measurement intersect, use a ruler to follow the lines extending from the point of intersection with the various scale on the chart. Try to be as exact as possible when using the chart to read the other measurement and mark your answer in the proper unit for that measurement. For example, if you know the dry temperature and absolute humidity reading, you can use a ruler to gather information about the dew point, relative humidity, and vapor pressure. Lastly, we need to visualize two measurements by comparing them on the chart. If you are calculating a change in any of the measurement over time, plot the point on the chart and gather all of the measurement possible for each point from the chart. From there, compare the difference in the temperature and make a note of how the change affected the air. This is especially useful for visualizing how a change in temperature, absolute humidity, dew point or vapor pressure affect relative humidity, enthalpy or specific volume. Okay, that's all for me. Thank you.
Question 1. With the help of psychometric chart, find the following properties of air. If air is at 26 degrees Celsius dry bulk temperature and 60% relative humidity, find dew point temperature, wet bulk temperature, enthalpy of air, and specific humidity of air. First, we will write down the data which have been provided. The given data is air at 26 degree dry bulk temperature and 60% relative humidity. First, have to see here, we have to got dry bulk temperature which is 26 degree dBT line. So, we have to take till it meet the curve at relative humidity 60%, and once it is plotted, then we extend this line. We got dew point temperature is 15.8 degrees Celsius. And when extend this line to the right side, then specific humidity we got as 0.0125 kJ per kg of dry air. And when we saw the specific volume line, so here we got somewhat near to 0.864 meter cube per kg specific volume. This inclined line is specific enthalpy line which we got 65.5 kJ per kg of dry air. So in this way, with the help of psychometric charts, we can determine different properties of air at 26 degrees dry bulk temperatures and 60% relative humidity. Question 2. Air is applied to a conditioned room at 17 degrees Celsius dBT and 50% RH. The air leaves the room at 25 degrees Celsius dBT, during which RH decreased by 5%. Find dPT of supply air, change in enthalpy during the process, change in specific humidity during the process. Show it on a psychometric chart. So first, we will write down the data which have been provided. The given data for properties of air at initial conditions is 17 degrees Celsius dry bulk temperature and 50% relative humidity. And for final conditions, it is 25 degrees Celsius dry bulk temperature and relative humidity decreased by 5%, that is 45% relative humidity. As you can see, dry bulk temperature has been increased from 17 degrees Celsius to 25 degrees Celsius from initial to final conditions. So here, you have to first mark initial and final conditions on a psychometric chart. Now, we have to process 1 to 2. First, we have to find out dew point temperature of supply air. So at point 1, dew point temperature is 5 degrees Celsius. Now, the next, we want to find out change in enthalpy during the process. So, enthalpy at point 2, which is H2, is 53 kJ per kg, and enthalpy at H1 is 33 kJ per kg. So, from the difference of enthalpy, we got change in enthalpy of the process 1 to 2. Now, we want to calculate change in specific humidity during the process 1 to 2. So here, specific humidity for initial conditions, that is point 1, which is W1, is equal to 0.005 kg per kg of dry air. And for final condition, the specific humidity, which is W2, is equal to 0.009 kg per kg of dry air. So from W1 and W2, we got change in specific humidity during the process 1 to 2. Question 3. Air at 25 degrees Celsius WBT, 25% RH is to be conditioned to 22 degrees Celsius dBT, and specific humidity is 11 gram per kg dry air. Determine heat transfer per kg of dry air referring to the psychometric chart. Represent the process on chart by sketch. Given data properties of air at initial conditions 25 degrees Celsius WBT and 25% RH. And for properties of air at final conditions 25 degrees Celsius dBT and specific humidity is 11 gram per kg. So first, we will write down the data which have been provided. Now, we have the process 1 to 2 and we want to determine heat transfer during the process 1 to 2. So in order to calculate change in heat, we need to find out enthalpies. at point 1 and point 2. So, enthalpy at initial condition, that is at point 1, is 77.5 kJ per kg, and at final condition of point 2, the enthalpy is 49 kJ per kg. By putting value of H1 and H2, we got the heat transfer per kg of dry air as 28.5 kJ per kg of dry air.